Hello guys and welcome back to Numboy. Today we're going to go over some intermediate value questions. So this is a question, I'm going to give you 4 questions, pause, have a go at them, and then we'll work through them together. So let's get straight into this. So our first question here is x cubed minus 3x plus 1 equals 0 in the interval 0 to 1. So as it's a polynomial, we know that this equation is continuous in the interval. So it's a good thing just to write that down. As it gets you a few marks, and then what we need to do is sub in both limits, and we need to see if it crosses this is a sign change, because then it proves that there is a root, as x has to there has to be an x value which equals 0. So first we're going to put in f0. So we're going to get 0 cubed minus 3 times 0 plus 1 equals, well, this is just 0 minus 0 plus 1 gives you 1. And now we're going to have f of 1. So we're going to have 1 cubed minus 3 times 1 plus 1. That gives you 1 minus 3, which gives you minus 2 plus 1 equals minus 1. So we can say that f0, f1 is less than fc, which is less than f0. So there exists a value c in the interval where f of c equals 0, and that proves that there is a root to this equation between the interval. Let's move on to our next question. So this is our next question. We have x to the 5 minus 2x to the 4 minus x minus 3 equals 0 in the interval 2, 3. And I'm going to write out the same thing I did last time. So this equation, let's make that an actual s, is continuous in the interval. And then we're going to put in our limits. So we're going to have f of 2 first equals 2 to the 5 minus 2 to the 4, which is just 2 to the 5 again, minus 2 minus 3. So this 2 times 2 to the 4 is just 2 to the 5. So 2 to the 5 minus 2 to the 5 is 0. Minus 2 minus 3 gives you minus 5. And then we're going to put in our f of 3. So we get 3 to the 5 minus 2 times 3 to the 4 minus 3 minus 3, and I'm going to quickly bang that into my calculator to get you an answer, and that gives us an answer of 75. So we can see that there's a change in sign, so f of c is between f of 5 and 75, so there exists a value c such that, or actually what we should say is c in the interval such that f of c equals 0. So that's the root to this equation here. Let's move on to our third question here. So this is our third question. It is x cubed plus 2x equals x squared plus 1 in the interval 0 to 1. So the first thing we're going to do is say our normal statement. And then the next thing we're going to do is move everything onto one side. So I'm going to move this across. X squared plus 2x minus 1 equals 0. And then we're going to bang in our limits. So that's a 0. So that goes to 0 cubed minus 0 squared plus 2 times 0 minus 1 equals minus 1. And our f of 1 is 1 cubed minus 1 squared plus 2 times 1 minus 1. So that's 1 minus 1, that's 0, plus 2 minus 1, it gives you 1. So we can say f0, fc, and f1. So there exists a value c in the interval such that f of c equals 0. And that's how you do it. We're going to move on to our final trickier question now. So this is our final question here. We have x squared equals square root of x plus 1 in the interval 1, 2. So I'm normally write like that sentence I always say about it being continuous, but I'm just going to bang straight into doing this question. So we're going to have x squared minus x plus 1 to the half. So equals 0. So now we're going to put in our limits. So f1 equals 1 squared minus 1 plus 1, 2 square root of 2. So that's just 1 minus the square root of 2, which gives you a value of minus 0.41. And now we're going to put f of 2 in there. So we get 2 squared minus square root of 3. So it gives you 4 minus square root of 3 to give you a rough value of 2.26. So as you see, there's a sign change here. So f of 1 is less than f of c, which is less than f of 2. So there exists a value c in the interval such that f of c equals 0. Thank you guys for watching this video. Make sure if you enjoyed it to hit the like, subscribe and comment any videos you'd like to see, and I'll see you in the next video. Goodbye.